Alright, good morning. How is everyone today? Everyone being all 11 of you. Good, good. Alright, good deal. So, the dedicated 11, exactly. Alright, so reminder, no class tomorrow, right? The whole school is closed, so any remaining questions on homework 7 dialogue, good chance to ask them today, since we won't meet again until Thursday, which is the day before the deadline. Woke up 5 minutes ago. Awesome. Good timing. I actually got up early today, and it's hard to get up early, but it actually felt good. So that works sometimes. All right, questions, dialogue, things like that. All right, well, let's keep going with regular expressions, and we went through, a few details of regular expressions. So a period, an asterisk, putting things in brackets with a caret to negate pattern match. Up at 5. Wow, that's impressive. Going to the gym is good. Let's see, I was looking at the time box thing in dialogue and noticed that you have to use the arrow keys to change the time. Was wondering if there was any way to change that. I think you can type the time in, actually. Let me see if I can pull up a time box really quickly. Nope, you can't type the time in. But you can arrow key each digit at least. Oh no, I can. So that'll me type in. Nope, looks like you're stuck with arrow keys. Well, that's a little unfortunate. But on the other hand, you don't have to use the time dialog to input a time. You could have them type in a time, in an input box or something like that. But yeah, time dialog seems like it forces you to use arrow keys. That kind of surprises me. You can also page up, page down. You can also do end and home to get to 59 or 0. So that's possibly useful. All right, is there any way to get rid of the P's and Q's that make up the border? Yes, absolutely. So let's see. So when you go into putty, let's see if I can get putty to come up here. All right, what you want to do is you want to go into, let's see if I can get it like first or second try, translation. So on your putty configuration, go to translation under window, and this last item here, enable VT100 line drawing. Checking that will change it from the P's and the Q's to actually doing like lines and things that make it look like the dialogue you're expecting it to. So that's useful. So if we don't check that, right, you get the Q's and the X's and stuff like that. So those are not what you want. So let's go up here. I don't know if I can change it in place. So run putty again. And translation, leave that box checked. All right, and that makes it look reasonable. So this is just, you know, it's not actually drawing on your screen because it's a terminal session. It's just sending ASCII codes. But VT100s, which is the terminal that putty is generally emulating, know how to interpret certain sequences of commands, usually beginning with an escape in a left bracket, to do things like drawing graphical characters. So it builds pictures like that. It's the same thing that you know, makes the steam locomotive work, for example. Because yeah, those lines are just ASCII characters, but they're from a different character set. They're not part of the standard actual ASCII character set. All right, cool. Other questions? All right, so substitutions in regular expressions. So we have, you know, these different things we can do to match for patterns. But there's this idea of substitute old with new. And possibly, you know, putting a G at the end, possibly putting lines on the beginning. But in this old pattern, we can put part of our pattern inside parentheses, and whatever matches that part of our pattern gets saved for us. So parentheses save the matching string. In what's called a register. And then in the new pattern, we can say, for example, \1, \2, \3, etc. And these are the contents of a register. And the first thing we put in parentheses gets thrown into register 1, the second thing into register 2, and so on. All right, so this is a lot easier to work with than to talk about. So let's go back into our file of names, and let's do the thing that I tried to squeeze into the end of class yesterday. So we already looked at how to replace the beginning of this, right? Everything up to a space. We saw how to match that pattern, so we could substitute beginning of the line followed by by any succession of letters followed by a space. And if we just replace that with nothing, right, that just gets rid of the last name. So let me show you an example of what we can do with this. So beginning of the line, but I'm going to put the following expression in parentheses. And I have to escape my parentheses with backslashes, so I'm not just matching up parentheses. So I'm grouping together the following pattern, which is bracket A through Z, any succession of those. And then I'm ending my parentheses. So those parentheses say start at the beginning of the line, right? And then anything that matches 0 or more upper or lowercase letters, throw that matching pattern into register 1. Okay? And that has to be followed by a space. And then I'm going to say match any succession of characters going all the way up to the end of the line. And take that matching pattern of characters and throw that into register 2. So what I'm doing right now is, Smith, John J. And I'm matching beginning of line, any number of those things followed by a space, followed by any succession of characters, followed by the end of the string. So Smith is going to match this. The space is going to match the space, and all the rest of this is going to match the dot star. And by putting these things in parentheses, and I won't draw my escapes on my parentheses, but by putting these things in parentheses, this is going into register 1, this is going into register 2. So what I'm doing is I'm matching a pattern, right? But I'm matching it in such a way that the last name, right, which appears first, is going to be saved in this temporary location called register 1. And the first name followed by an optional space and middle name is going to go into register 2. And what I'm going to do is replace all of this with register 2, a space, and register 1. And what that should do is take this string and turn it into this string followed by a space followed by that. Okay, so it's going to take the last name which appears first and it's going to put it at the end. And so if I make this substitution on all the lines, right, our file just changed to John Henry Smith, Barney Rubble, George Awkward Jetson, etc. And I think I forgot to eat that space in the middle. I think I forgot to include that. So let's do that again. So beginning of the line, any succession of letters, I'm going to end my parentheses there, so that's register 1 followed by a space, and then any succession of letters followed by the end of the line. Let's replace that with the last name and the first name, right? So there's a simple swap that we've done. We've basically taken everything up through the first space and thrown that at the end of the string. Okay, so you'll hear me say this a bunch of times when we're talking about this. This is never something you memorize, right? You never want to write this down in your notes and say, oh, I need to change my string accordingly. What's the regular expression to do that? What you want to do is learn the mechanics of writing these regular expressions and be able to work with those. So let's do some simpler examples. Suppose I wanted to reverse the first two characters of a string. So I wanted to change this into B, A, C, D, E. So there's two steps, right? First, you have to somehow get a hold of the two things that you want to manipulate, and then you write an expression involving those two things in whatever way you want. So how do we grab those two things? Well, if I search for a pattern starting from the beginning of the line and I just search for the first two characters, those will correspond to, you know, the letter A and the letter B. So I'm going to say substitute beginning of the line dot dot. But I'm going to throw these into a pair of registers, so I'm going to put parentheses around them. And I'm going to have to escape my parentheses. Those are actually going to be backslash paren. Once you start writing the backsplashes, it becomes a big mess. So I'm not going to put them in here, but this is basically saying take this first letter and put that into register 1, take the second letter, put it into register 2. And if I just replace those two with backslash 2, backslash 1, that will replace the first two characters with the second character followed by the first character. So here's A, B, C, D, E, substitute beginning. There's our first character. There's our second character. Replace it with backslash 2, backslash 1. That flips around the first two characters. So we're using VI as a way to do this interactively, but you can do this a number of places. Mostly we're going to use it in a utility called SED, S-E-D, which is a stream editor. It's a batch version of VI. But lots of things speak regular expressions. There's libraries you can call from C that will process regular expressions. Java has a regular expression class. Perl does regular expressions. There's lots of ways that we can use this. And the specifics of the implementation are basically the same. Sometimes you don't have to escape the parentheses, sometimes you have to escape brackets, but the idea is always the same. So we'll keep doing this in VI for a little bit, and then we'll branch off into SED. So suppose you want to repeat the first letter of each line. You want to repeat it 3 times. So 1 through the last line, substitute, and I'm just going to match the beginning character. I'm going to replace it with 3 copies of whatever I matched. And so the first character of each line gets tripled. Alright, if you want to duplicate the last character of each line, it's equally easy. I'm just going to match a period followed by $, which says, you know, this pattern will match any character as long as it's at the end of the line. And if I replace that with 3 copies of itself, then, you know, each line gets the last character tripled. But this gets slightly harder if you want to do something like duplicate the second character of each line. Because we need a way to get to that second character, and really the only way to do that, or the easiest way to do that, is beginning of the line, dot, dot. And this is the second character that I want to replicate. But if I just replace this with, you know, backslash 1, backslash 1, backslash 1, I've got a problem. Because the pattern I'm matching is actually the pattern consisting of these first 2 letters, and this, as it's written, would replace those first 2 letters with just 3 B's. So what you really want to do is, since we're matching this first character, put that in a register 2. And then we can replace this pattern with the first character and then 3 replications of the second character. But if we don't throw this thing in a register first, we're going to lose it in the substitution pattern. So beginning of the line, first character goes into register 1, second character goes into register 2, and we're going to replace that with register 1 and then 3 copies of register 2. And so the second character got tripled. All right, so this is the basic game we play with regular expressions, and it's, you know, like many things in programming, it's a bit of a puzzle box. You have some change you want to make, and you need to figure out how can I describe what I'm trying to do in this language. And there's websites that will let you play with this, that you can go and type a string in and then type in a regular expression, and it will show you what it's doing and how it's matching patterns. Okay, regex101.com, suggestion from someone. Yeah, this is a good one. So, let's see, insert your regular expression here. Okay. Yeah, so you can type in a pattern here, and it will highlight what it's matching, and it will show you the information over here. So if I search for any character followed by any succession of characters followed by a space, you can see the greedy behavior, where it's matching all of the characters up to and including the last space, as opposed to just matching THIS and a space. And so on. And so if you put things in parentheses, it throws those into, they're calling it a group. And so if I search for a dot star followed by a space, group 1 is eating up that first character T. Group 2 is eating up everything up to but not including the last space, right? And so on and so forth. I haven't played with this in a long time, but you can change the flavor of it apparently, and play around with substitutions and so on and so forth. All right, so here I'm replacing that pattern that I matched with group 2 followed by group 1, so there's what my substitution string will look like. So there we're replacing the first 2 registers with the 2 registers in reverse. There's the output string. And there's a reference at the bottom. That is cool. So sites like that are useful to play around with this stuff, if you don't like just banging on VI. But anyway, so this is as I've said, it's easier to write these things than to read these things. But once you get the knack for it, it's really easy to do some bizarre edits on lines, and just crank out these 20, 30 character long strings of random looking stuff that does what you want to do. And that can be useful. All right. So I think I have some practice problems somewhere for regular expressions that I wasn't able to find quickly this morning, but I will try to post those on Canvas for people to play with. But that's the basic idea. All right. Regex just tend to look like banging on the keyboard took place, random keys abound. Yeah, totally. And like I said, don't try to memorize these things, right? Try to figure them out. Let's say we want to get rid of the second space on a line, right? So we want to get rid of that space, and we want to get rid of this space, and we don't want to make changes anywhere else, right? So what would I try to do? Well, I'd try to find, basically I'd look for last space on a line. So I would look for a space followed by anything that's not a space, any succession of those followed by the end of the line, and I would replace it by whatever matched this stuff, right? So if I have, this is Sparta, this matches a space, and then the longest succession of non-space characters I get is the I and the S, and that's not followed by the end of the line. So I can't match this pattern starting right here, but here's another space, and the longest succession of non-space characters following that is this, and that is followed by the end of the line. Alright, so this pattern would match all of this stuff. If I throw this part in parentheses, that will match the stuff following the space. And so if I substitute all of this and put these in parentheses, and just substitute that with the contents of register 1, that would get rid of the last space. So I say all right, so it's a puzzle box. It's a different way of thinking about things. And when you process a regular expression, there's a lot going on, right? There's I mean, this exercise we just did here, there's lots of different ways that we might try to match this pattern, right? Theoretically, you would want to start with the first character and say, does the first character match this pattern? And if not, does the second character, does the third? And this is easy because there's, an actual character in the beginning. But if you have something with wildcards and asterisks and brackets, right, there's a lot of places in here where you might start to match a pattern, but you would discover that, I can't get all the way to the end of my pattern matching my string starting at that point. So you move to another point and you try. And you might, choose to stop the first part of your pattern here and start matching the second part, but there's this whole tree of possible ways to interpret a regular expression against a string. And the underlying hardware, software that does the regular expression matching takes care of all of that for you, right? You just need to know sort of what these are supposed to do and how to write them. So when you put things in parentheses, they automatically go into registers. And the first set of parentheses, whatever matches that, goes into register 1. The second set goes into register 2, the third and 3, and so on. And I don't think there's an effective limit to how many registers. I mean, probably, a few 100,000 or something, but effectively I don't think there's a limit on that. and then the backslash is just followed by the register number starting with 1. And most languages have support for regular expressions. So in C, there's a regex package, so you can get the prototypes from regex.h. And I'm not going to go through this in a lot of detail, but basically, most of these languages, what you do is you write a regular expression as a string, and then you compile it. You turn it into some internal representation, because these are basically little programs that need to be executed. So there's a regcomp function that takes a string, which looks like a regular expression, and returns the address of a regex_t structure. So this is I don't know what this was supposed to do. I think it was just a test. So just matching some patterns and throwing them into registers. So you compile that string into a regular expression, right? One of these regex structures. And then you can say regular expression execute, right? Pass it the regular expression, pass it the string that you're trying to match. I don't remember what the 3 is, but then matches is an array of these regmatch_t objects, right? And the things that match your regular expressions will go into here. So 3 is how many registers I have available. And then when you run through this, right, it will basically break up your string. It'll tell you if the string matches or not. That's what status is. And if it's 0, it did match your expression, and the things that matched each piece have gotten thrown into these objects. And these objects have a RMSO, RMEO. I think that's the start and the end location in the original string that matched that particular register pattern. Right? So we're not going to play with this. You can definitely dig into it if you like. We're not going to go into this in here. We'll get into this in Java in 223. But it's available, right? Java, there's a whole class for regular expressions. But it's basically the same drill all the time. You take your expression, you compile it to some internal format, and then you basically run that against strings, and it does something to tell you what matches and whether the whole thing was a match or not. And so this is useful, if you're doing parsing, for example. So, let's say you want to write a compiler. Well, what is an include statement? It's a number sign followed by the keyword include, followed by, optional spaces, and then either a quotation mark or an angle bracket followed by some kind of path, and then a closing angle bracket, and then possibly a comment, right? Well, what's a comment? A comment is either, 2 slashes or a slash followed by a star. What is white space? Well, it's a space or a tab or a new line or maybe some other things, and it could be any succession of these. Right? What's a path? Well, it's a directory followed by a slash followed by a path, or it's maybe a slash followed by a directory followed by a slash followed by a path, or maybe it's a slash followed by a directory, or maybe it's just a directory, right, which could be a file. And so you can define the structure of, what a valid include statement would be. And you do this by passing your work on to other things, for example, things that know what a valid path is. When you define a function prototype, what is it? Well, it's either nothing or void or a variable type, followed by white space, which is mandatory, followed by a valid name of a function, followed by parentheses, and then a list of variable types, followed by an optional star or multiple stars. etc., right? And you can define all of these things using regular expressions. There's other ways to do this too. But this is how you would go about starting a compiler, right? Something that would analyze the structure of an input program and tell you if it's valid syntax or not. But while you're checking the syntax, you can also be starting the process of actually compiling this. For example, if I know that this parses as a valid path, and I've thrown that path into somewhere in memory, a register, right? Well, what do I have to do when I run my preprocessor? I have to open up the contents of that path, that file, and pull it in, and replace this line of code with the contents of that file. If I know that this is a valid function declaration and I've saved the name in a register, I use that to build up my symbol table, which says, you know, when you see the word myPrint, that's a function, here's what it returns, here's the argument list. And so parsing is part of compiling, and it's definitely part of syntax checking, but it's also part of the translation process. I think it's a really good exercise to think about how you would write a compiler. And you know, if you have some time, if you want a project to brush up your C skills, if you want to, you know, think differently about some of this stuff, make yourself a compiler, make up a language, right? It doesn't have to be the next great language that everybody adopts, but make up a language. Something simple, right? Maybe something that lets you do basic arithmetic and assign values to variables and print. Yeah, I remember your regex parser, because I think you showed some of that in Discord. That was pretty awesome. And think about how you would make something that basically takes an input file and, you know, either compiles it into something or interprets it. So you could make a file that, you know, sets variables equal to expressions and prints out their values. And maybe, you know, start just letting variables be equal to constants and print out the values of variables, one per print statement. And then let variables be simple expressions, maybe just addition and multiplication. And then let them be arithmetic that also includes other variables. And this really gets you a lot of practice, you know, not just coding in C, but sort of thinking about organizing information and so on and so forth. Maybe I'll do some part of that for the last programming assignment. I don't know. I got to figure out the last programming assignment still, but I want to get that posted in the next few days. Yeah, grouping and regular expressions would be tricky. And this will tie into hash maps and associative memories, which we're going to talk about in a few days in Bash. But those make your life a whole lot easier if you're trying to do compilation or parsing or things like that. All right, so I'll put some practice problems related to regular expressions up on Canvas. But let's take a look at sed. So sed is the stream editor, right? It's the stream version of ed, which is an old editor that is the non-visual version of VI. So I can, you know, edit my file names, and I can look at, you know, line 1 and line 2 and line 3 and so on. And I can make changes to these, and I can insert. I don't remember how to get out of insert mode. There we go. Right, so now I inserted a new line, hello, into my file. And I don't remember how to exit this without, I'll probably Control D. Yeah, I don't remember id. So sed is a way to do that editing session, but do it in kind of a batch mode, right? So you can basically put together a bunch of commands and have it process your file accordingly. So sed is built on the idea of mostly processing a file line by line. Okay, awk, which we'll talk about probably Thursday and Friday, processes a file field by field. It kind of goes across each line of the file and breaks it up and manipulates it. Sed is more about going from line to line. All right, so let's play around with this. So here's a really simple sed program. Okay, so I'm going to pick on a file of foods for no particular reason. Nope, I'm not going to do that. All right, so here's a sed program. So this first part is a line number, right? And this second part is a command or a program that we want to execute when we match whatever this first field says. So if I just put in a number 3, that means this matches line 3. I can put in a regular expression to search for a pattern, different things like that. I'm just going to put in a line number 3. And this command P is one of the simplest commands. It just says print. Okay, so this first line of my program basically says when you get to line 3 of the file, print it out. And then the second line says when you get to line 4 of the file, print that out. And then the last line says when you get to line 4 of the file, and here the Q is another command which says quit. So this is going to read from our input file. It's going to print out the 3rd and 4th lines, and then it's going to exit. And I'm looking for something here. Bear with me a second. All right, so let's run this. So I'm going to do sed, and I'm going to put in the name of the program here. So I'm going to say -f to say the program is in a file P1, and let's just run this on foods. All right, and I get 6 lines of output. So let's take a look at this. Okay, so here's line 4, here's line 3. And what my program output was a copy of line 1, the apple one, copy of line 2, which was banana, a copy of line 3, and then a second copy of line 3, and then line 4, and a second copy of line 4, and then it quit. All right, so sed normally its basic function is read from an input file, right, or standard in, and copy each line that it reads to standard out. So if I just run sed with no program, right, just an empty argument, and I give it a file name, it acts like cat. It just reads the input file, sends it to my standard out. Okay, so that's the normal behavior. If I do a sed-n, it suppresses that normal behavior of copying standard in or an input file to standard out. And so in this case, with no program, it doesn't produce any output. Okay, but if I go back here and I run my program P1 and I say don't normally copy standard in to standard out, it will only output in response to my two print statements in my program, which says print lines 3 and 4. And so now I've extracted the third and fourth lines from my file, Oreos and Kiwi. So this would be one way to take a file, and if you wanted to look at, you know, some range of lines in the middle of it, it's really easy. It's, you know, a few lines of a program. All right. So our general program structure is basically, you know, some sort of pattern and some sort of instruction. And our pattern could be a particular pattern that we're looking for, or it could be a line number or something like that. And yes, P1 is a sed program. It's a really simplified sed program. And when you run sed, right, you can say sed, and you can, you know, list a program right here, and then an input file. But if your program is complex at all, if it's got more than you know, just one line to it, you can do a -f and a program file. And so that's what we did here, when we said read the program from the file P1. All right, so we can match, you know, a pattern. We can have a line number. We can have a pair of line numbers. We can do something like, you know, / regular expression to search for some occurrence of something in that input line, and so on. So let's say we want to print out all of the fruits. So there's a program which says look for the pattern fruit, and when you find it, print out that line. And if I do this, remember the default behavior is to copy the input into the output. So we see all of our lines, but some of these lines got duplicated, all the ones that had fruit anywhere on them. So if I put a -n in the beginning, the effect is more clear. This just prints out any line that has the word fruit in it. So these lines right here. And if we want cookies, right, we just get a list of cookies. All right. So instructions, there's a lot of instructions we can use. We can use P for print. We can do an A for append to add something to the end of the line. We can do an I for insert to insert a line before the current line. We can do a C for change. And there's a variety of instructions we can perform. And we are out of time. Wow, that was short. All right, here's the plan. I will post some practice questions to think about for regular expressions, and Thursday we'll go through those as a class. So be prepared to play around with regular expressions. and then we'll do a very systematic exploration of sed, look at some sed programs, and then we'll go ahead and we'll talk about awk, and that should take us through the end of the week. All right, have a good rest of the day. Have a good day off tomorrow if you have the day off, and I will see you on Thursday. Thanks.